This comes out of section 7.3, derivatives of other trig functions. Instructions here are simple, even if the question isn't. It says differentiate. Y equals 2 cosecant squared 3x squared. I find students have a bit more success when they write this as cosecant 3x squared inside the bracket and square the whole thing. Just puts it more in terms of what they've seen before. Y prime then is going to be, so the 2 just sits out front, put the 2 there. But now we had something being squared, so we need to have 2 times cosecant 3x squared to the 1. Now we have to multiply by the derivative of cosecant. Now the derivative of cosecant is ugly enough in itself. It's negative cotangent times cosecant. And then finally, we have to multiply by the derivative of the innermost function there, which is just 6x. So if you look at it like peeling out the layers here, we've taken the derivative of this squared function, which was the outermost layer, then the cosecant function, which was the next one in, and then the 3x squared function. So it's like 3 levels of chain rule. To simplify that, really there's just a little bit of multiplying. So 2 times a negative times 6x, so negative 24x can come out front here. I've got cosecant and cosecant, so we can definitely say we've got cosecant squared 3x squared, and we still have this cotangent 3x squared. So again, you could change things to sine and cosine and whatever and try to make it look a little bit better, but at least if I can see it that far, you've used the chain rule effectively, which is the main thrust of that question. Now let's try another. This time we're given tan y equals x squared, and we're asked to find y prime and y prime prime, the first and the second derivatives of this. Hopefully it jumps out at you right away as implicit differentiation. I need to start off by taking the derivative of everything with respect to x. So I'm going to have secant squared y times y prime equals 2x. So y prime equals 2x over secant squared y. It doesn't really make sense to divide by secant squared y when you can just say 2x times cos squared y, which is the same thing. So there's your first derivative. I threw in the second derivative here just because in the last couple of, on a midterm, on a chapter 2 test, I've seen the second derivative here give people issues as soon as they have to do implicit. So the derivative of that is the second derivative. Now to do that, I'll need to use the product rule. Say, okay, 2x times the derivative of cos squared. So that's 2 cos y times negative sine y times y prime. Now, plus cos squared y times the derivative of 2x, which is much simpler, which is that. The place a lot of people are having troubles here is realizing that, without doing any other of the simplifying here, y prime, we have an expression for y prime. We need to replace that with 2x times cos squared y. We don't just leave y prime in there. And so, I've got this, let's put the 2 there. This thing's does simplify a little bit, but really that's what I want to get at, is the fact that when you differentiate the first derivative, you get the second derivative, but you get this y prime term in there often, and you have to deal with it. I've got 2 times 2 times 2 times a negative, so I've got negative 8x squared. I've got cos cubed y times sine y, and then I have plus 2 cos squared y. So I suppose this thing would factor a little bit further to say, well, let's take out a 2, let's take out a cos squared y, and we could write this as negative 4x squared cos y sine y plus 1. Doesn't really make it that much better looking, but at least we factored as much as we could for the first step. So there's derivatives of other trig functions. We'll use them in the next examples to do slopes of tangent lines or concavity or asymptote, do various questions that will jump off of that.